Now, what is the purpose for having these multiplication and power rules? Well, the purpose is to take problems that look like this and make it simpler. So let's look at some steps here. It says multiply the coefficients as normal. I'll show you what that means. And then one variable at a time, determine the number of exponents by adding. That, remember, multiplying same base, you can add the exponents. But right here, this is a pretty important idea. When in doubt, write it all out. Or write it all out. So let me show you what that means. Notice we're multiplying 3x to the fourth, y to the second, times 4x to the first, y to the third. There's a big multiplication sign here, but honestly, this means all multiplying. This means 3 times x to the fourth times y to the second times 4 times x times y to the third. Now, a little hint I want to give you is anytime you have a single variable, what's its exponent? Don't say 0 because it exists. X is here. So it's 1. That becomes really important. Now I'm going to show you maybe a couple extra steps here that you don't have to do, but look at how this is being multiplied. Everything is being multiplied together. Well, we know the commutative property of multiplication says that we can multiply in any order. So I am going to multiply the 3 times the 4 first. Then I'm going to take my x terms. I have x to the fourth times x to the first, and then I have my y terms times y to the second times y to the third. Now you don't have to do that step, but now we can see that if we go 3 times 4, that's 12. That's multiplying the coefficients as normal. 3 is a coefficient, 4 is a coefficient. Then we have same base multiplying, we add the exponents. Same base multiplying, we add the exponents. Oops, I said add in the row multiplication sign. I'm sorry. These are adding. So this becomes 12x to the fifth times y to the fifth. And notice I even got rid of the dots. When you have numbers by variables or variables by variables, you don't need that. It's assumed that this means multiplication. Now let's look at another example. And these examples, guys, they're pretty involved, and there's a reason I'm showing you these. The ones you have to do in your homework won't be this involved. So if you can handle this, you're good. When in doubt, write it all out. 2 times a to the third times b to the fourth times c. Times, notice this negative a here? I'm going to write it as a negative 1 times a, because there's really a 1 in there, 1a, times c to the fourth. Again, guys, you don't have to write down this next step, but I'm going to just show you it so you can understand what we're doing. We're going to multiply the coefficients. So 2 times a negative 1 times, I'm going to add up my a terms, keeping in mind that this a has an exponent of 1 and so does this c. So I'm going to go a to the third times a to the first. All I'm doing is rearranging things. B is all by its lonesome. And then we have our c's. C to the first and c to the fourth. Okay. Multiply. 2 times negative 1 is negative 2 times a, same base, multiplying, add it. 3 plus 1 times b to the fourth times c to the 1 plus 4. And don't add these together, guys. Remember, it says one variable at a time. So this becomes negative 2, a to the fourth, b to the fourth, c to the fifth. So those are the last those are 2 examples on using our multiplication steps. Now we're going to focus on our power to power steps. So when you look at a problem like this, okay, remember what this means is we're taking negative 2 times x to the third times b, and all of that is being raised to the second power. Now the way I think about it, you gotta be careful. This is not the distributive property. The distributive property is multiplication over addition. There's no addition here. But remember, this 2 here doesn't just belong to the b. Okay, it belongs to everything inside the parentheses. So that's why I kind of think sometimes of it like a distributive property, even though it's not. So I'm going to take negative 2 the second times x to the third to the second times b to the second. Okay. So -2 times the -2, that's what, remember, repeated multiplication, equals a +4 times 1 base power to a power. We multiply the exponents. And then we have our poor little b here. So this becomes 4x to the 3 times 2 is 6, b to the second. One more example. All right, same thing here. Be careful that you don't just give this 3 to the b to the 5th here, because it belongs to everything in parentheses. So I can give this 3 to the 3 here, 3 to the 3rd, times a to the 2nd raised to the 3rd, times b to the 5th raised to the 3rd, times 2 times a, I'll put a 1 there, a to the 1st, times b to the 2nd. Now whether you choose to move things all around together or not, I'm going to do that. 3 to the 3rd, 3 times 3 is 9, times 3 is 27, times 2, times my a terms here. This is 1 base, power to a power, we multiply the exponents, times just a to the 1st over here, times, oh, our b's here. This becomes b to the 5 times 3, which is b to the 15th, times b to the 2nd. All right, guys, then just keep simplifying. 27 times 2 is 54. Over here we have a to the 6th times a to the 1st times, oops, same base. Well, I'm just going to write it out like this, and then I'll change it in the next one. So we have 54, oops, 54 times same base multiplying, add them, 6 plus 1, times same base multiplying, add them up, b to the 15 plus 2. That gives us 54, a to the 7th, b to the 17th. Phew! These will get confusing, guys, so it really is important to write it all out and take it step by step. If you can get through these, you can absolutely get through your homework problems.